Welcome to this screencast on annotating images using Fiji with Weka. Let's start by preparing our data. Assuming we have created the labeling directory under the user root of your favorite operating system. In my case, it's Windows, so the labeling directory will be created under users Boris labeling. And three directories are images, masks, and Weka. Images is obviously where the images will go. Masks is the directory for the work product. And Weka is the directory for a couple of Weka files that we're going to save along the way. So let's get started. I assume that the annotation tool is already installed and running on your desktop and is displaying this toolbar. Let's load the first image into it. This can be done in a couple of ways. The easiest is to drag and drop the image into the toolbar, just like this. The image appears. Now we need to set up our Weka workspace, and this is done by clicking on Plugins, selecting Segmentation, Trainable Weka Segmentation. This will bring up this window, and it will also bring up the log window, which will show you the progress of all the operations that you perform. It's a useful window to keep track of your work. Now, to navigate this window and annotate successfully, you need to resize it in such a way so that the entire image is visible. Alternatively, it's possible to zoom in and zoom out by clicking on plus or minus key on your keyboard. So let's resize our image. Since we are doing it for the first time, we need to set up a classifier. Click Settings, and make sure the segmentation settings dialog box looks like this. We select Sobel filters, difference of Gaussians, variance, neighbors, balance classes, and we call our classes class 1 positive. This will be our buds or canopy, and negative, this will mean everything else. Also, click on Fast Random Forest. Just click on the bold Fast Random Forest, not on the Choose button. It will bring up this dialog, and we will change the number of trees to 16. Now click OK. Click OK through, and we are ready to start segmenting. You can use any of the tools on your ROI toolbox. I prefer to use the circle for the buds. So click on the circle and start clicking and selecting buds. We try to be as close to the real bud as possible, but it may not be possible in all cases. That's okay. Now, if you selected something by mistake and added it to your positive class, to the buds, it's possible to remove it. Selecting that entry in the box selects this in the image. Double-clicking on the entry removes it from the image. So this is how you fix your mistakes. So let's select a couple more buds. And that should be enough. So we also need to teach it to recognize not buds, which is going to be easy. We just select large areas which are not going to be buds, don't contain any buds, and add them to the negative. We're now ready to train the classifier. Hit Train Classifier. This is going to extract features, and then it will train for a while. You can observe this behavior on the status bar of your Fiji window, or you can look at what's going on in the log window. So now we are done. And we didn't do too badly, but still lots of pixels belonging to actual leaves were classified as buds. This is not good. and we need to fix it. So in order to fix it, we just keep annotating. We select the wrongly classified areas and add them to the negative. If you aren't sure if anything was selected correctly or incorrectly, the toggle overlay button is very handy. This returns you to the original image. This brings back the result. Let's select a few more mistakes and train again. This time training should go much faster. And sure enough, this cleans up our image very nicely. So the last step, we are done classifying at this moment. It's time to create the result. Hit the Create Result button, and you will get this mask. In order to clean it up, we first clean up all the messy single pixels spread all over this image. In order to do that, select Process on your toolbar, Noise, Despeckle. So that cleans it up some. Next thing to do is airbrush this thing manually. In order to do that, select the eyedropper tool on the toolbar. Then click anywhere on the green to make sure that your eyedropper is green. Now you are ready to paint the green pixels over the wrongly selected red pixels. So where are we going to paint now? Let's take a look. So there is this huge blob in the middle that you could probably use some cleaning up. So in order to clean it up, select the brush tool, and the brush tool may originally be set to the width of 10 pixels. Double clicking on it will bring up this dialog, and you can increase the number of pixels that determines the width of the brushing tool so that it's more convenient to work with. So now we can go in airbrush. So what about this cluster here? If I toggle overlay, I can clearly see that they don't belong to any bud. So yeah, so they need to go. This image is rather large, so yeah, remove stuff here, remove stuff here. Oops, I probably removed too much. Hitting Control Z will restore what I was doing before. So let's not go wild with airbrushing. Let's remove that here. How about this cluster? Well, I can go back. I can toggle overlay. Yeah, that's a false positive again. So I need to remove this. And everything that's in general longish, like for example, this here is just these are parts of the pipe. Oops. So we need to brush this away as well. This small thing dot, however, is clearly a pixel, a bud identified by our classifier, so we need to keep that. And this needs to go. All right, so it looks fairly good. Let's make sure we've gotten the entire image. Maybe remove something here. This is too big, right? And we're now ready to save it. So we saved the image into the masks folder. And the key is that the image needs to have the same name as the mask needs to have the same name as the original image. So how do we do that? So first of all, since this was our first run, we need to save the classifier. Click Save Classifier. Go to our Weka folder. Here we are. The file will be saved under classifier.model. Hit save. It's going to save the classifier. The next thing we need to do is save the data. And these are the steps we will only do once the first time we label. So hit save data, accept the default name, and it will be saved to the same Weka folder. So now, close the workspace. You may get prompted for whether you want to save it or not. Select no. You will be returned to the original image. Now save this original image into the masks folder by selecting Save As from the File menu, selecting PNG, going back to the root labeling folder, selecting Masks folder, and saving. So we aren't done, because all we've done right now, we've saved the original image into the masks folder. And here's why we've done that. This image is called classified image. The output, the final product, needs to have the exact same name as the original image. So instead of typing this insane name and making typos in the process, we do this trick where we first save the original image into the masks folder, and then we overwrite it. So make sure you have this, you click on this image, select it, now File, Save As, PNG, select the image that you already saved here. You will be able to see it because it will look as an original image, and click Save. Replace, select Yes. So now, if I look at it again, I will see that the mask is saved under the original image name, and that's what I wanted. Okay, now you can close the mask. Select the original image by clicking on it. Click Shift-O. So now we have navigated to the next image in our images folder that we haven't yet classified. And this image is fairly easy because there are no buds in it. So how do we classify it? Let's take a look. So first of all, we set up our workspace by selecting Plugins, Segmentation, Trainable Weka Segmentation. We get our workspace. We don't need to go through the classifier setup anymore. You just need to hit Load Classifier, navigate to the Weka folder, select Classifier Model, wait while it loads. Here it's loaded, and you can proceed with annotation. Select the tool that you like, select the region, select the region. This isn't going to be very exciting. Now hit Train Classifier. You get an error message. Cannot train without at least 2 sets of examples. So it's expecting some examples of the positive class, but you don't have any examples of the positive class. So what do? This is where the data we have saved before comes in handy. So if you get this error message, click Load Data, and navigate to data.rf file that you saved before. Click it, select it, click Open. And now your classifier will train. Hit Train Classifier. And it will take a while because even though there are no buds, it's going to take its task very seriously. It will featureize the entire image and then train the classifier. Now the image is classified. Well, we've got some false positives, but that's not a problem. We're going to brush them out in the next step. Alternatively, of course, we can try and fix that without airbrushing. We can select those bad regions, add them to negative, select this, add to negative, train classifier. So the classifier is now training. This shouldn't take that much time. Here we are. So now it looks like we are all green. So let's create the result. So the result is created, and it doesn't quite look all green. So let's apply our airbrushing steps to it, because you see there is a region of a few red dots right here at pixels. So process, noise, despeckle, and pretty much all of our red dots are now gone. But still, since the green color is already selected and we have the brushing tool, let's just give it a once over with the brush. So that's probably good enough. It looks all green. Now, no additional steps, no need to save the data, no need to save the classifier. Just close your workspace. If you are prompted to save it, answer no to the message box. Save the original image into the masks folder by clicking Save As, selecting PNG. Go to the masks folder, save it. Now select the result, so it's classified image. Go File, Save As, PNG, and you know precisely which image to select. We select this one, save, replace it, yes, please. So to verify, yeah, here we've got two masks whose names are matching the names of original images. And at this point, we're done. We need to upload the images to the Google Drive.